In the world of AP statistics, we need to get used to using random digits tables. A computer's randomly generated digits, and they've put them all in a long string. Every number is equally likely to be selected. We need to use this because it verifies that a student knows what they're doing and can demonstrate it when they're working with anything involving random samples or simulation. Later, we learn how to use the calculator to randomly generate integers, and it's a lot faster and more practical, but we got to learn how to do this. So, suppose we're going to give 4 gift certificates randomly to 10 different people. Since there are 10 digits in a decimal system, 0 through 9, then each person could be assigned one of these 10 different digits. And then we go to one of the lines. The problem will say go to line 105. So we go to line 105, and when we get there, we say, okay, we're going to take the first 4 people, the first 4 digits that are different. So, line 105, first digit is 9, so we select that one. Next digit is 5. Now the next digit is another 5, so we're not going to use that one because we already have a 5. Likewise, there's a 9, we already have that, we're not going to use it. Then there's a 2, that's different. Then there's another 9, can't use it. And then there's a 4. So the 4 people selected are 9, 5, 2, and 4. We're going to learn about a stratified random sample first. Stratified means there's strata. In this case, there's 3 different levels of employees in this company: management, full-time, and part-time. From within each strata, we're going to decide to randomly select a certain number. We're going to take 2 managers at random from the 8. We're going to take 8 full-time employees and 2 part-time employees. Got to do it randomly. So we go within each strata, one at a time, and we go to the random digits table. 8 managers, 2 selected. We need to use 8 digits. We have 0 through 9 available. Let's not use 0 because we don't have to. Let's start with 1, and we'll number them from 1 through 8. So these are the 8 people. If we see a 0 or a 9 in the table, we just ignore those digits because they don't match up with an actual human being. So this time maybe we'll go to line 104, and we're going to randomly select the first 2 managers in this string right here. So if we go to line 104, we see a 5, so we're going to select manager 5, and then we see a 2. So that's it. We got those 2 selected, and we're good. Then we go to the next strata. We have 72 full-time employees. We have to randomly select 8. Well, now we need 2-digit numbers to be able to number all the 72 people. So we could start from 00 through 99. That gives us 100 distinct 2-digit numbers by using 00. But we'd argue that if we don't need all 100, we're probably going to start with 1 and go through however many employees we have just so it doesn't get funky. So any 2-digit number that's in this range will match up with one of our full-time employees. We need 8 of them. Let's go to line 109 this time. So we go to line 109. And we need 8 of these employees. Well, the first 2-digit number is a 36. That's good. But the next 2-digit number is 00. That's not assigned to any of our full-time employees, so we ignore it. Then we get a 91. That's not in our set. Neither is 93, but 65 is. So our first 2 people out of the 8 that we select are 36 and 65. Continue through these string of digits until you find the first 8 distinctly different 2-digit numbers. So if we kept going through here and we found another 2-digit number that was 65, we wouldn't use that one because we already have person 65 selected. We'd skip it just like we skip the 2-digit numbers 00 or 91 because they're no longer in our range of people that we're selecting from. We go to our 3rd strata, the part-timers. We need 2 people from a group of 16. Well, 10 digits is not enough to match up with 16 people, so again we're forced to use 2-digit numbers, this time from 01 through 16. The problem is if we see a 00 or any 2-digit number between 17 or 99, we've got to skip those and keep looking for the first 2 2-digit numbers that are in that range. Maybe now we're going to line 102. So we go to line 102, we see a 73. That's not any one of the 16 people we have. 67 is too big, 64 is too big. We get a 71, a 50, a 99, a 40. Oh man, a 00, that's not in there either. A 19, that's no good. 27, 27, 75, 44, 26, 48, 82, 42, 53. Will it ever end? 62, 90. Holy crud, we've gone through the whole string. We have nobody selected. So we go to the very next line and we start over from there. 45, 46, 77, 17, close. Finally a 0, 9. Holy smokes, that's our first person. Now we got to get the second person. 77, too big, too big, too big, 0, 0 again. Dang, 95, 32, 86, 32, 94, 85, 82, 22, 69, 0, 0, 56. And then we come down to, where are we? Down to like this line down here, 95, 59, 29, 04, 29, 40, and 07. There we go. Blah! Finally, person 7 and person 9, they're the ones that are selected. So it can get tedious, it can be a drag, but that's how you use the random digits table. So the stratified random sample, we took 12 people altogether from a population of 96, but we didn't just take 12 out of the 96, we took them small samples out of each of the strata. That's why it's called stratified. Now, the mother of all sampling techniques is the simple random sample, the SRS. Two parts of the definition. Everybody's got to be equally likely to be selected, volume, and every subset for the population is equally likely to be selected, or every sample of size n. So we need to explore this because we're definitely going to be tested on this notion right here. So in our sample, we had 8 managers, we had 72 part-time employees, and we had 16 full-time employees for a total of 96 employees altogether. So we're going to do this time, if we take a sample of size 12, this time we're taking it from the entire population. So we're going to number the people from 0, 1 through 96. The only 2-digit numbers we didn't use are these 4 right here. So if we get any of those 4 digits, they don't line up with anybody, so we don't use them. Now let's say we're going to line 108. So we go to line 108. The first 2-digit number that's in our range is 60, then 94, then 07. We keep doing that until we get 12 employees, 12 different numbers that are in this range. This would be an SRS. Well, the big question is, why was the stratified random sample we took not an SRS, not a simple random sample? Well, it violated 2 parts of the definition of the SRS. First of all, that, just a second, I am going to select this baby, I'm going to copy it, and I'm going to create a new frame because we are going to explore this from 2 different perspectives. Let's go back here. Okay, everybody. So why was our stratified random sample not an SRS? Well, it's because not every subject was equally likely. See, in our population, we had 96 people altogether, a total of 96 people. If we take a random sample of 12, then every person has a 12 out of 96 chance of being in our simple random sample, in our SRS. This simplifies to 1 out of 8. So you would have, everybody would have a 1 out of 8 chance of being selected, so everybody would be equally likely to be selected. But that's not happening when we took our stratified random sample. Because if you were a manager, you knew we were going to take 2 out of those 8 managers. Well, when you select 2 out of 8 managers, that simplifies to 1 out of 4. Every manager has a 1 out of 4 chance of being selected. But if you go down here to the part-timers, we were definitely only going to take 2 out of 16. That's 1/8. That's a 1/8 chance of being selected if you're a part-timer. It's a 1/9 chance of being selected if you're a full-timer. So not every subject is equally likely to be selected in a stratified sample like they are in an SRS. Now, sometimes it's possible to make your stratified random sample match this part of the definition of an SRS. And that could happen if we did this. We need 1 out of 8 people, right? If we're taking a sample of 12 out of 96, everybody should have a 1/8 chance of being selected. Well, we could make sure that happened if we chose to select 1 out of the 8 managers. That would be a 1/8 chance of being selected if you're a manager. Take 9 out of the 72 full-timers, because 9 out of 72 is also a 1/8 chance. And we'd still take 2 out of the part-timers. That's 2 out of 16. That also is still a 1/8 chance of being selected. So we can make it so that the first part of the definition of an SRS is obeyed if we take a stratified random sample, but usually it's violated. Now, the part of the SRS definition that is always violated is this one, and it can kind of hurt the brain. So see if this makes sense. We need to make sure that every sample or subset of size n is equally likely. In other words, once again, if we had all 96 people and we just took a sample of 12 out of those 96, do you agree that there's no stipulation that you have to have 2 managers or 8 full-time employees? Heck, it's possible that out of that 96, you could get 12 people and they're all full-time employees. So that would be a sample of 12 people taken from the population where all of them are full-time employees. That's a possibility if you take an SRS from the entire population. But alas, if we take a stratified random sample like we did, we are definitely in our sample of 12 going to end up with 2 managers, 2 part-timers, and 8 full-timers. So a sample like this coming out of the population has absolutely no chance of being a sample that we end up with because we've stratified it and we've made sure that we're going to get 2 of these, 8 of these, and 2 of these. So there's a bunch of different combinations of 2 managers, 8 of these, and 2 of these that could happen, so they all have a chance of happening, but there is no way you're going to get a sample of 12 people where all of them are full-timers. So if we can find one type of sample that has 0 chance of happening, then we've shown that such a sample, such a subset, is not equally likely to occur with a set of 2, 8, and 2 in it. That's the one we're going to have to work on as time goes by to get us ready for being tested on our understanding of all this. Then we have a multi-stage random sample. So we could have, let's say, a certain country. Mother Russia. Okay, no, the United States. And what we're going to do is we're going to say, let's chop this baby up into 6 regions. Region 1, 2, 3, 4, 5, and 6. Now, if we take a multi-stage sample, then here's what's going to happen. We're only going to randomly sample a couple of these regions because we don't want to send people flying all over the place to have to get samples all over the country. So the main reason for a multi-stage sample is to narrow the search and narrow the places we have to go to get a sample, to make it easier. So let's say we only randomly select 2 of these regions. I don't know, maybe it's these 2 regions right here. Now, the other ones we aren't even going to go to. But after we select a region, so we'll select 2 regions, then after that, the next layer is to go in there and select 2 states at random from within each region. So maybe we get Arizona and Nevada from this region. Maybe up here we get Minnesota and Wisconsin or something like that. So we're down now to where we only are going to travel to 4 states out of all 50. We're layering it down. We're whittling it down. We're taking a multi-stage approach. The last thing is we might randomly select, let's suppose, 3 counties from each of those states. And so we'll go into 1, 2, 3 counties here, 1, 2, 3 counties here, 3 counties here, and 3 here. And we'll randomly select from those counties, we'll take an SRS of 50 people. So from each of the counties, we're going to end up taking 50 people altogether. That is a multi-stage thing, so that all we have to do, instead of traipsing all over the country to find people, we just go to 3 counties here, 3 here, 3 here, and 3 here. That's a total of 12 counties in which we're going to end up taking a sample of 50 people. So in the end, our sample size is going to be 12 times 50. We're going to sample of 600 people, but we only had to visit 12 counties to accomplish it. You can see it's not going to give us a very good cross-section of the whole country. We're missing the attitudes or whatever, the perceptions or beliefs of people in the South or whatever. So it's not a very representative sample, but it is cost-effective. Stratified, on the other hand, if we go back to what would happen if we stratified this, well, if we did a stratified and we still started out with the same 6 regions, in a stratified sample, we would go into each region and we would randomly select, let's say, 100 people here, 100 here, 100 here. We'd take 100 people from each region and we'd still end up with a sample size of 600, but this is stratified. We make strata or groups, and within each group we take a sample for a total of 600. That's different from multi-stage. You take the 6 regions, but you only select 2 from the states within each region, you only select like 2 or whatever, or 3. It just all depends what you decide. But that's multi-stage. That's stratified. Okay, then there's cluster sampling. Suppose we're at a conference and at lunch they have breakout sessions. So they're putting anywhere from like 20 to 30 people together in a room, they're eating their lunches, and they're talking about the business of the day. Well, let's suppose we want to take a sample of maybe 100 people at this conference. So we're going to kind of make the assumption that these groups have been put together fairly randomly so that each group is a fairly good cross-section of the whole population. Well, if that's the case, then we can use cluster sampling. Out of the 17 rooms that each have anywhere from 20 to 30 people in it, we might randomly select 5 of those. Maybe this guy, and this guy, in this room, and randomly this one, and then this one right here. Then we will go into each of those rooms and we'll sample everybody. We'll take a census, which is what you call a sample, where you sample everybody in that particular little population. So cluster sampling, we're going to go into each of those things, but we're not going to take a little random sample in those. We're going to sample everybody in each of those rooms. That's cluster sampling. Convenience sampling. 2 kids are arriving at school, right? And one of them reminds the other that survey that they were supposed to take as part of their project that was assigned 3 weeks ago is due today. So one of them panics and he says, whoa, I got to hurry up and take a sample of 10 people. So they run over and they grab the first 10 people they can find and they get their sentiments on a survey that they had to fill out. Well, that's not a good cross-section of the population. So a convenience sample is pretty much garbage. It just was convenient to go get those people. They weren't randomly selected. And the problem here is maybe all these people are coming out of the senior parking lot, whereas the other door around the other side might be where a lot of kids who walk to school or the underclassmen go in that door. So we're really getting a biased sample. We're hearing from more of the seniors and we're ignoring the sophomore and freshman students. So it's a biased sample. It's not a good cross-section, so convenience sampling is garbage. The last one is the systematic random sample. Suppose we have 90 people and we want to take a sample of 10 of these people. Well, we can number them from 01 to 90. We can start with the first person and we can add 10 to that and get to the 11th person. Add 10 to that and get to the 21st person. Add 10 again and again and again and again. And in the end, those 9 people, okay, like I said, we're going to take a sample of 9. We're going to take a sample of 9 people. So we're going to add 10. We're going to jump by 10s so that in the end, we end up with 9 people, but we did it systematically. Once we decided how much we needed to jump by, we just went from the first person to the 11th person to the 21st person. We keep taking every 10th person until we fill our sample of size 9. Well, the problem with that is it's not random. It's just, hey, you're taking the first person, then you know it's going to be the 11th person and the 21st person. Not everybody's equally likely to be selected like they would be in an SRS. So the big question would be, how do we make it so that, let's say, the 32nd person is just as likely as, let's say, the 35th person to be selected, which is just as likely as the 31st person. So here's what we need to do. We need a starting point. We need to make sure everybody's equally likely to be selected. So since we're going to jump by 10s, we look at the first 10 people that we could choose from. We could assign them each a digit, and we would go to the random digits table, like maybe row 3, and the first digit we see is a 4. So we'd come back here and we'd say, oh, okay, well then what we're going to do is we're going to start with the 4th person, the person 04. And now we're going to add 10 to get the next person in the survey. So we're going to go to the 14th person, add 10 again. We're going to get the 24th person, add 10 again, the 34th person. So that made the 34th person just as likely as the 31st person to take part in our survey. So at least it kind of makes everybody equally likely. So again, the way we do that is, once we figure out how much we're going to jump by to get the right sample size, in this case a sample size of 9, then we say, well, if we're going to jump by 10s, then our first little group of 10 let's go in there and let's randomly choose where we should start in that group. So we'll start at 4 and we'll jump from there. So example of that would be, where am I? Keep going. Here we go. Let's suppose we have 450 people at a conference. We want to select 30 of them to receive a free dinner certificate. So what we're going to do is we're going to say, well, we want to choose every 15th person, because if we divide 450 by 30, the sample size, that gives us like little groups, little subgroups of 15. We'd have one group of 15, another group of 15, another group of 15. We would have 30 groups of 15. So as long as we can find a taking off place, a random starting point within those first 15 people, then we can, within those first 15 people, then we can keep jumping by 15 to get to the next group. And in the end, we'll end up with 30 different people that were in this group of 450. So what we do is we say, well, we got 450 people, we want to select 30. So our formula is going to be to use this constant k, which would be to take the population size divided by the sample size. So again, 450 divided by 13 means we should jump by 15. So k will be 15. So we have our first group of 15 right here, and even though they'll be numbered 001 through 015, because we have to account for all 450 people and give them all a distinct number, to make it easy for ourselves, we're going to go to the random digits table and just stipulate that we need to find who do we start out with in this group of 15. So all we have to do is number them with 2 digits from 01 through 15 and go find that first 2-digit number in that range. So we can go to the random digits table, maybe it's line 7, and we say, no, 82, that's no good, 73, 95, 78, 90, 20, 80, 74, 75, there it is, 11. So we go back here and we say, okay, we randomly selected the 11th person as the person we're going to take off from. So everybody had pretty much an equally likely chance of being part of our survey. Well, now from there it's systematic, so we are going to bounce by 15 each time. So it's the 11th person, add 15, it's the 26th person, add 15, the 41st person. We'll just keep adding 15 until we make it near the 450, and when we're done, we will have 30 people in our sample, but this has been done systematically. A systematic sample is never an SRS, because in your group of 30, there's certain combinations of people that can't possibly happen. They're not equally likely. So for example, you can't end up with 2 people next to each other that are going to end up in our sample of 30. So you found one example that can't happen, so we violated the second part of the definition of an SRS. What we've tried to do is make the first part of the SRS definition obeyed by saying, hey, let's find a place to start off with, then we'll keep adding 15, so we've pretty much made it so that every person's equally likely to be in the sample, but not every subset. There you go. That's an introduction to sampling techniques.